So looking at 38 and 39 here, we are still factoring the polynomial completely. And if we take a look here at 38, we've been given 75a squared minus 108b squared. All right, well, first things first, let's go ahead and see if we can factor a GCF out. And actually, I think we can take a 3 out of here, can't we? So if we pull a 3 out as our GCF, we'll be left with 25a squared minus, and then 108 divided by 3 is going to give us 36b squared. All right, so now that we've pulled out our GCF, we go to question number 2. How many terms are we dealing with? Well, 1 and 2. When we have 2 terms, we should automatically be thinking difference of perfect squares or the sum and or difference of cubes. Well, we're not dealing with cubes because these would have to be 3's, but we are dealing with difference of perfect squares, right? We have a subtraction, and hopefully 25 and 36 are jumping out at you as being perfect squares. So we have 3. Let's go ahead and create 2 sets of empty parentheses. And now what's the square root of 25? Well, 5. Let's split this a squared up into a and a. And then what's the square root of 36? Well, 6. Let's split this b up into b and b. And then because it's a difference of perfect squares, we do plus minus. And we are finished with 38. See, these aren't too bad, right? 39, let's take a look at, and we have 98c to the 4th minus 18d to the 4th. All right, question 1, is there a GCF? Well, let's see, we know they're both even, so there definitely is a GCF of at least 2, and I think that's going to be the only thing we can pull out. Right? I don't think there's anything higher. So let's go ahead and take out a 2, and if we do that, we're left with 49c to the 4th minus, and now 9d to the 4th. All right, so now that we've dealt with question 1, is there a greatest common factor, a GCF? We can go on to question number 2. How many terms are there? Well, 1, 2, so we should be thinking difference of perfect squares or sum or difference of cubes. Well, we're not dealing with cubes here, but we are dealing with the difference of perfect squares, right? So let's go ahead and we have our 2, create our blank set of parentheses. What's the square root of 49? 7 and 7. We're dealing with not just a 2 here anymore. Now this is a 4, so let's go ahead and split this c4 up into c squared, and then we can go ahead and do plus and minus. The square root of 9 is 3, so 3 and 3, and let's split this d to the 4th up into d squared and d squared. And there we have it. The 39 factored as a difference of perfect squares. Now be careful here, because did you notice right off the bat it didn't look like these were the difference of perfect squares, but that's because you have to ask yourself that question number 1, is there a GCF? And if you don't go through those sets of questions, you may not recognize this as being a difference of perfect squares, because 75, 108, 98, 18, those are not perfect square numbers, right? You'll remember in a previous video we listed all the perfect squares. 1 squared is 1, 2 squared is 2, so on and so not 2, 4, so on and so forth. So if you know that list, and you really should memorize 1 through 10, you'll know that 98, 18, 75, 108, those are not perfect squares. And so again, you really have to make sure that you pull out a GCF, and only by pulling out a GCF did we reveal a hidden difference of perfect squares. All right, let's take a look at the next set of questions, 40 and 41.